Hello, and welcome to a short lecture on standard sequence methods for Introduction to the Art of Programming Using Scala. If you have not already watched the short lectures on the basics of arrays and lists, and you're not familiar with arrays and lists in Scala, you should probably watch those before you watch this, as this will rely on some of the material that was covered in there. So, we've already seen that arrays and lists are these sequences of values. They're collections. They allow us to have, for example, a single name that can be related to a whole bunch of different values. Something like that. So nums here is a single name, and it refers to a list of int. Could have done that same syntax for making an array. And it has a bunch of numbers in it. And we looked at the fact that we could index into arrays or lists using something like this. This actually gets the sixth element because we start counting at 0. So 0, 1, 2, 3, 4, 5. And it gives us back the 3. Now, at this point, we want to look at some of the other standard methods that exist on these types. We saw that in the case of a list, we could do things like call head and tail. We also saw that there was a method for getting the length of a list or an array. And all the methods that we're talking about here are methods on the general sequences in the Scala collection, so they work for both lists and for arrays. Turns out they will also work for strings. Actually, let's go ahead and let's make a val here so that we can use that as a short name. And turns out those same methods that we were using on our list will work just as well on the string. Now, this isn't necessarily an efficient way to process the string with head and tail, but all of these will work, and some of them will work reasonably well. It's interesting to note the fact that because these methods work on the list, which is immutable, turns out string is immutable as well, that even when you're doing these on an array, they do not alter the array itself. They have the same behavior on all of these types. And so because they work on immutable types, anything that would appear to alter the collection doesn't. Instead, it gives you back a copy of it. So we saw that we have head and tail as methods for getting out parts of sequences. Another method that is similar, so instead of having the head, you can ask for the last element. And so 8 is the last element of nums, the period is the last element of the string. There's a method called init, which gives you everything but the last. So whereas head and tail kind of go together as a pair, head gives you the first, tail gives you everything else. Last and init are a pair, where last gives you the last element and init gives you everything except for that. There are also some nice methods for getting parts of a sequence. So for example, if you only wanted to get, say, the first 5 values, you can use a method called take. And so take 5 gives you the first 5 values that are there. The counterpart to take is drop. So just like you can, instead of giving you back the first 5, it gives you everything except for the first 5. Pass in whatever value you want. There is also a method called take right, which instead of giving you things from the beginning, gives you things from the end. And once again, these will work just as well on a string. So our str dot take 4 gives us back the first word, this. Other methods that we have, split at is a method. If you call split at on 5, note the return type here. And if we do that on nums.split at 5. So nums.take5 gave us 15754. 15754, same list. When you called drop 5 and got everything else, it was that list. Notice those two are the same. And split at gave us back both of them. It gave us back a tuple of list int, list int. If we call it on our string, it gives us back a tuple of string string, where we get the first n elements when we pass it in a value n, followed by everything after those n elements. Another interesting method that you can call is distinct. Distinct gives you back all of the elements that are unique inside of a collection. So for the string "this is a test," these are really only the unique characters in it. All this, and then everything else is a repeat. After that first space, the I is a repeat, the S is a repeat, the A is unique. Of course, the spaces are repeats of the first spaces. The T is unique, the E is unique, the S is a repeat, the T is a repeat, and the period is unique. And so we get just that for the distinct values. Nums, due to the horrible random number generating capabilities of my fingers, actually only has 7 unique numbers in there. You can also use a method called patch in order to create a modified method. And so the patch method, you tell it where you want to do the patch on. Let's say on element 8. And I want to put in a list of 99, 88, and I want to replace 2 things. Now, patch takes 3 arguments here. The first one is where to start doing the patch. I set at index 5, 0, 1, 2, 3, 4, 5. So our original value, nums, had 3 and 6 in the indexes 5 and 6. This patch put in a 9 and an 8, and it used that, the 99 and the 88, and it used them to replace 2 elements, which is how many I had here. If I just wanted to make a longer list that still had the 3 and the 6, I could do this. It's worth repeating. Nums, being a list, is immutable. That original nums is still completely intact. None of these operations that I'm doing are altering it in any way. They're giving me back a completely new collection. Another method that you might find helpful is slice. So slice gives you elements from one particular index until another. The first index is inclusive, the second one is exclusive. So 0, 1, 2, 3, 4. Whoops, I'm on the wrong one. 0, 1, 2, 3, 4, 5, 6, and it didn't give us the 8. It only gave us the 3 and the 6. If we had asked for 0 to 3, we get back the 1, the 5, and the 7. We don't actually get back the thing that's at index 3 there. So those are methods that give us back either parts of the collection or values from the collection. and they give you back the same type. When I called them on strings, it gave us back new strings. When I called them on list, it gives us back a new list. If I had an array here I was playing with, it would give us back a new array. There are also some methods that can be used to give you back Boolean values, and we've seen some of these. For example, with our lists in a previous lecture, we saw that we can check to see if they are empty, and kind of the companion to isEmpty is non-empty. Of course, nums isn't empty, but just to demonstrate that we'll get true if we call it on something that is empty, remember nil is the name for an empty list, and sure enough, when you ask nil if it's empty, it says yes. Other methods that will tell you about conditions on a collection, one of them is starts with. So actually, let's intentionally introduce a typo here. Does str start with this? No, because it actually starts with a this with a capital T. So you can pass this that starts with a collection, and it will tell you if it starts with the same thing. In the case of nums, we could ask if it starts with the list 1, 5, 7, and the answer should be true, because that is what it starts with. If I replace the 5 with an 8, we get back false. The counterpart to starts with is ends with, and so we can check what our string ends with there. You can also ask if a collection contains a particular value anywhere in it. So as you can see, there's both a contains and a contains slice because I hit tab. If you just ask for contains, you're asking if it contains a single value. So for example, does nums have the value 9 in it? Turns out it doesn't. Does it have the value 6 in it? Yes, it does. So that will just give us a Boolean back. All of these methods are giving us back Boolean. And that contains slice method will tell you if it contains a particular set of values. So 1, 2 does not appear. 5, 7 does appear inside of there. Okay, so those are a number of helpful methods that you can use to test for things. You can find things inside of your collections. So for example, we saw that nums does contain the 6. Where is the first 6 in there? Well, we can find that by using index of. And it says that the first index of the number 6 is at index 6. 0, 1, 2, 3, 4, 5, 6. Sure enough, there it is. What if we wanted to find the last index? Because there's another one. Well, there is another method called last index of, and here we see that this occurs at index 11. So you can find where things are. What happens if you ask for something that's not there? Because we saw that nums does not contain a 9. If you ask for something that's not there, it gives you back an index of -1. Remember, indices always start at 0. There is no -1. So this is a value that tells you that nothing matches what you asked for. There are a collection of other methods that are kind of handy to know about. One of the best ones is mkstring. So if you just call it and don't pass it anything, what it does is it, as the name implies, it makes a string for you. And it takes all the elements and sticks them together. We saw in the arrays video that arrays do not print nicely when you're using them in a script. For example, print line array 1, 2, 3, well, gives us something like that, which kind of looks like garbage. If you just call it with a make string, you get that. Especially in a case like this, it would be nice to see that they're separated. Well, it turns out you can pass make string an argument. If I just want to separate them by spaces, I can give it a string for a space. If I want a comma in spaces, I can do that. Put whatever you want. There's also a longer form that takes 3 arguments for something to add before all of the elements, a separator, and something to add to the end. Most of the time, though, you'll just want to do this and pass it a single argument. You can reverse elements. Works on lists as well. You can convert a list to an array, and then you can convert that array back to a list. You can even take your string and convert it to a list. String becomes a list of char, or to an array, in which case it becomes an array of char. 2 methods that are kind of interesting to note are zip and zip with index. The term zip should probably bring to your head this idea of a zipper, and as you move it up, you have elements kind of put together. That's exactly what zip does. So if we were to look again at what str and nums are, when you zip them, the 1 got paired with the t. And so you get back a collection of the type that you have, that you're calling to start with. Nums is a list, so I got back a list. But it's a list of tuples, where the first element is the type that's stored in here, and the second element is the type that's stored in there. So 1 and t, 5 and h, 7 and I, 5 and s, etc. Along with that, let's do this for sometimes it's just nice to pair things up with their indices, and if we do that, we can do that with the zip with index method, and it gives us back a bunch of tuples that have whatever the first type is, followed by an int for the index. Now you'll notice this has spit out an interesting type here, an immutable indexed sequence. You can't, obviously, this is not a valid thing to put in a string. Strings are characters only. So when we did zip with index on a string, it had to use something else. And it decided to use something called a vector. A vector is kind of like a cross between an array and a list. It's immutable, just like the list, just like the string, but it can be accessed more efficiently, like an array can. The last method that's worth pointing out is called diff. And what diff does is it gives you all of the characters from, let's do is test. It runs through the first collection, and it takes out things that it finds in the second collection. So in this case, I'm taking out the letters is space test from this is a test. And you can see what happened there. Turns out that I is actually this I, though in some ways it doesn't matter, because the I, S, and space right here got pulled out from that. If I were to want to take out 1, 1, oops, several 4s and 6s from nums, that happened to be enough to remove the, I only had 1, 1 to start with, but any 4s and 6s that appeared in there, they're gone. Okay, so diff is just an interesting method for you to know about, mainly because it's a method that's very hard for you to write on your own, and so it's nice to have it there when you need it. Distinct is similar. Distinct is also a challenging method for you to write on your own. So what I want to do is to quickly write a little method, and the goal of this method is it is supposed to average groups. So first let's pass in, I don't know, a nums is a list of double. So I want to take this list of doubles and I want to break it into groups of a particular size. So I'm also going to pass in the size for how big each group should be. And after breaking them up, it's going to take the average of each group and return that to us. So it's going to give us back a list of double. And we are going to write this recursively, but we're going to need some of the methods that we just saw in order to do this. So first off, we need to, we're going to write this recursively, so it has a base case. Well, the base case is going to be any time when the list has size elements or fewer. So for example, if we had 25 elements and we're supposed to be averaging them in groups of 10, we'll get a group of 10, a group of 10, and then a group of 5 at the end. So if nums.length is less than or equal to size, well, that is our base case, and we want to give back the list that contains the average of those. So nums.sum divided by nums.length. Else, if that's not the case, then we want to pull off the first 10, or not the first 10, pull off the first size of them, take the average of those, and cons that onto the front of a list that is everything except for the first size of them. So we'll make a variable, call it first. It's for the first size elements. And in order to get this, I need to pull that many elements off of nums. That's what take does. And so we have, that gives us the first size elements, and what we want to return is the average of that. First.sum divided by first.length, and cons that onto average groups, where we're going to call it all with everything except for those first elements. So we want to get rid of or drop the first size elements, and we're going to keep going with the same size. So this method will run through all of our values and take averages of them in the appropriate size. How about we do this? Val n equals list of 1.0, comma. I just need a bunch of numbers in here. I made the first one 1.0, so it'll force the whole thing to be a list of doubles. Let's load in that file average groups on n, and let's average in groups of 3. So the first 3 are 1, 6, and 4, which when you add them all up you get 11, and you divide by 3, and so you get 3.66. The next group, 7, 9, and 5, averages to 7, and etc., etc. You can tell where that 87 came in because we get an average that's well above 10. Now, just to help illustrate this, there are a number of ways in which this method is less than ideal. And we've talked about the fact that calling length on a list is less than ideal. We're not going to worry too much about that right now, but calling take and then following it with a call to drop is inefficient in the sense that both times it's going to have to run through, and there is a method that will do both of those for us at the same time. So what we want to do is make a second version of this. Make sure that our recursion calls it. And instead of using take and drop, we are going to use split at. Now, remember, split at returns a tuple. And so we can use the tuple assignment pattern match here so that the first size elements go into first and everything after that goes into rest. And then instead of having to call drop here, we can just call rest. And that way we're not calling those two methods. It's an interesting thought experiment for the student to think about how we might go about making it so that we do not have to call length here. And the hint that I will give you is to use split so that you can get away from that. Let's actually try something here. In dot split at 100. Okay, just so you can see what that does. If you split at a value that is bigger than the size of your collection, I did not type in 100 numbers there, you get all of the elements that are in there followed by an empty list. So that's your little hint on how you might do this without ever calling length at all. And change your base case around and therefore make it so it's more efficient for working on lists. Well, that's it for this little lecture. Hopefully you enjoyed it, and you should work on some exercises where you can solve some problems with these collections and using these methods.